Hello everyone. Today my very important topic of quantum mechanics, time dependent perturbation theory. There are large number of problems in the quantum mechanics in which Hamiltonian means total energy of system depends on time. So perturbation method can also be applied for such a problem in which Hamiltonian depends on time. The Hamiltonian of system is given by h is equal to h naught plus h dash, where h naught is unperturbed Hamiltonian and h dash is the Hamiltonian that is perturbed part. If we take time dependent Schrodinger equation, h psi is equal to I h cut diver psi upon diver t, and h is replaced by h naught, then the solution of equation is known, that is given by this. But if we replace h by h naught plus h dash, then their solution is unknown, and such unknown wave function is the linear combination of known wave function, and known wave function is given by this. So unknown wave function psi rt is equal to the linear combination of all known wave function, that means summation a and t phi n e to the power minus I e n t upon h cut, where en is the energy of nth state and ant is the expansion coefficient, linear combination coefficient. Now putting in time dependent Schrodinger equation, h psi is equal to I h cut diver psi upon diver t, h is equal to h naught plus h dash, psi is equal to this, is equal to I h cut diver upon diver t, summation n a n t phi n e to the power minus I e n t upon h cut. And separating each term, multiply each term, you will get the four individual terms, this, this. If we apply h naught phi n is equal to en phi n, then this term is cancelled out by this term. So remaining term are summation n a n t h dash phi n e to the power minus I e n t upon h cut is equal to I h cut a n dot t phi n e to the power minus I e n t upon h cut. And this can be written as in this form. If we multiply by phi k star, मतलब किसी भी फाई के किसी टर्म का मल्टीप्लाई करिए उसके कॉन्जुगेट टर्म का और इंटीग्रेट कर दीजिए ओवर द स्पेस, बट द टर्म इज टेकन other than phi n, just like phi k star, multiply by phi k star and integrating, then you will get a n t phi k star h dash phi n, this is equal to h dash k n, and this is equal to Kronecker delta k n. This term will be 1 if n is equal to k. So in summation n is equal to k will be necessary, otherwise this term will be 0. So summation replaces by putting the value n is equal to k. So this term becomes ant h dash kn e to the power minus I n t upon h cut. I h cut a n dot t n is equal to k a k dot t e to the power minus I n is equal to k this term. So ak dot t is equal to this, and this can be written as this. Now we want to separate the different order with the help of last equation. So we assume the linear combination constant an is in the form of series, and ah dash kn is the perturbed Hamiltonian is replaced by lambda h dash kn. Now putting in left and right hand side, and ek minus en is replaced by omega kn, angular frequency omega kn. Now equating the coefficient of various power of lambda, such as lambda ki power 0, then you will get a coefficient ak dot 0 is equal to 0, and lambda ki power 1 coefficient you will get ak dot 1 is equal to this. This is a first order perturbation. Now take coefficient of lambda ki power 2, you will get the second order perturbation. Now the detailed study of different order perturbation. First is zero order perturbation. Now take the equation of zero order perturbation. ak dot 0 is equal to 0. On integrating, ak 0 is equal to constant in time, written as Kronecker delta km. Its value is 1 if k is equal to m. Its value is 0 if k does not equal to m. Now take first order perturbation equation. On integrating, you will get this term. We are interested only those cases for where the system is initially t barabar 0 in the mth state, so that all k ak0 are 0 except am0 is unity. But n is equal to m, then its value is 1. If n does not equal to m, then their value is 0. So it is necessary that n is taken to be m. The perturbed H dash has induced transition to other state, मतलब एक स्टेट से दूसरे स्टेट में ट्रांजिशन हो जाएगा, and after a time the probability that the transition to kth state is given by ak1t mod square. Since ak1 is the value given by this equation, so ak1 1 upon I h cut h dash km n is equal to m e to the power I omega kmt dt. Now take a special case constant perturbation. H dash km is independent on time for a short given time period. So taken out from the integral, and you will get ak1t is equal to this 0 से t e to the power I omega kmt dt. On integrating, you will get this term and this term. e to the power I omega km t by 2 is taken out from the bracket, then you will get this. After solving, you will get this value. So probability of transition from mth state to kth state is given by ak1 mod का square, mod का square, and that is represented as pm2k. Conclusion: since sine theta upon theta is equal to 1 if theta tends to 0, so our term this equal to t by 2 and omega km t by 2 is equal to 0. So omega km tends to 0, ek minus em बटे h का tends to 0 या ek tends to em. This indicate that probability of transition will be maximum if ek tends to em, मतलब omega km is equal to 0. मतलब omega km is equal to 0, the curve has maximum peak. And probability of transition from m to k is given by this equation. Now take another value omega km t by 2 is equal to pi 2 pi 3 pi dot 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 km is equal to 2 pi by t 4 pi 1 t dot 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 dot, then this equal to 0. So probability of transition is 0, मतलब this point, this point, this point. Now plot the curve, you will get the maxima at omega km is equal to 0. In this way, area under the curve is, the width of the curve is 2 pi by t, 2 pi by t, 1 by t, and height of the curve is t square proportional to t square. So area under the curve is t square into 1 by t proportional to t. That is the time of application of perturbation. This is similar to single slit diffraction pattern. Note AK1T is maximum if EK tends to EM. That is, energy states are continuous. This is the end of the lecture.